Hello, pipe designers. I would like to talk to you today about tie-in. In particular, the sketches that I have done today are to remove a blind flange and a bolt-up connection type of tie-in in a revamp, turnaround, existing unit, however you want to call it. I'm assuming y'all know what a plot plan is, a P&ID, piping plan, piping spec, and I'm assuming that y'all know or have some S3D, a little bit of S3D background. I would like to start out by saying that in piping design, blind flanges are typically used for positive isolation, future connections, and maintenance access. And sometimes they'll put a bleed on it to bleed it off for in case they need to vent or make sure they're going to work in it. Let me slide into the ones that think are most common that I've dealt with in the past. But this scenario that I have here is this one here is the on an existing line. It's the let's just say it's the line, and then we got the OLET, and then we got the flange, and then we got the blind, and then we have the bleeder. Of course, this one doesn't have the bleeder. This one has a block valve and a bleeder, which is in some cases is considered a double block, which some clients request have that. And then this is just here. This one here is just a blind on a flange. For talking purposes, probably in a rack or something, or in a pipe. Sometimes they leave them. And then this is what I'm trying to represent here is just a plan view of the valve with the blind on it, and in the flange with the blind on it. In some cases, those are left for future projects or expansion. Let me see here. Let me look at notes. I made it a point to ask. I've made it a point to ask the clients on what these blind flanges are on the existing lines. It's something that, as a designer, or the design lead or your piping engineer lead needs to talk with the owner or operations or somebody that does maintenance on these pipes in an existing scenario. It's always to have their input as to what they use them for. Sometimes they need it. Sometimes they need an access port into that line, depending on the size of the line, but they'll tell you if they need it, or they go use that for flushing. Sometimes I've had that they needed that for flushing. So what we did, we went back. Let me see if I can sketch it up for you right quick. But when they have flushing, they'll more likely have a valve on there. Let's take this off. They'll take this off, and then they'll come in with their hose and with the flange, and then they'll come out with their hose and do whatever they got to do, and they'll use it for flushing. But they'll tell you. That's why it's a good idea to have the question asking them what needs to be done. How does a designer know what blind flange to use? I would say the designer needs to have a P&ID directing them. Then the P&ID needs to be walked down or looked at or put eyes on the particular point on the line. That should be, I'm assuming if you're at this stage, you've done that before, or you can do that. Um, take a look at my notes. To understand what a pressure class is, again, you need to know what the P&ID shows, but what the pressure class for the, like say, for instance, this is a 8-inch line, and it's 150 pound. So we know this is an 8-inch, it's 150 pound flange rating. So with that flange rating, you'll have your bolts, your gaskets, and everything that has to do with this this connection type. I guess the one I'm talking about is this connection type, because this is our tie point here. And we'll need to know, yeah, the size, 8-inch, 150 pound. And then say this is carbon steel. And then this will be our tie point of conversation. For now, that has a block. So let's keep going down my list here. In some cases, you need to do a field walk down. I think I've said that. Also understand the flange components, which we know we need the bolts and the gaskets, so that's got to be verified. Let me look at my notes. On this type of tie-in, when we're removing the blind, it accounts for the line needs to be isolated or what needs to be done for this. So we need to take into account whether this line can be isolated. This one here can be isolated. This one can be isolated. This one here cannot be isolated because there's no isolation point. So this one will need to walk down further into the on the P&ID to see if we have some kind of an isolation point further downline or upstream or somewhere. But this needs to have a valve to isolate it and another valve to isolate it. So this type of tie-in here, this scenario, there is no isolation for it. Same thing for this one here. There is no isolation for it, but we do need to, it does have a bleed, so if it's at a high point, that's good. But again, we'll need to find an isolation point, or think of an isolation point while you're doing your design. It's always a good practice. Clear this off so that we've discussed this is a tie-in, tie point, and this is a tie point here for the blind. This one's the same situation. This one can't be isolated, and of course this one here can be isolated, and this one here cannot be isolated. It's just something that you need to take into account when you're looking at your design thought process of how it needs to be approached. One thing I need to talk about, or maybe make a video later on, but I need to make a video. I think I should make a video on a tie-in package that persists or has the tie-in information, tie-in picture, tie-in ISO, tie-in P&ID, tie-in list, and then a description of what the tie-in is with signatures for construction managers and operators and everybody to sign off on to get approval of the location, which becomes very, very critical in the P&ID. And a process engineer needs to take a look at it also. Getting a little off topic here, but let me know if we need to create a video for that. I'm assuming y'all know what that is. So other design considerations we need to take into account. will be stress. So I've got a little sketch here with stress, little ISO tie-in point scenario, but we got our vessel here. Let me zoom in a little bit. We got our vessel here, for instance, and then we got an ISO view coming out. We've got a tie point here, and I just put another tie-in point over here just to help out on the sketch. Sometimes you may have the situation, sometimes you're not going to have this situation. Personally, in my personal career, there has not been that many tie-ins that you get away with to having a bolt up. Unless it's adding a unit that they pre-did or pre-allowed for material and tie-in points. I've had those in my career, but those were far and few and in between. Most of the time it was cutting pipe in a revamp situation. Sorry, I need to keep you all entertained here. But anyway, the point I was trying to make here is, oh yeah, and I got this tie-in point here. So let's get back to this. In this scenario here, where we have the first tie-in, of course we're going to remove that blind and the bleed, so then that will be able to be bled off, which construction will greatly appreciate that. But we'll also bring in our line, right? So then our tie-in will come in here, and let's just try to follow the same. We'll follow this elevation here. So say the line comes out and then comes back across this support here. See what that does for us. And then say we'll catch this support here. Here we'll catch this support, bring it out. And then this will be our line here. Yeah, that's not right. I'm sorry. Back up a little bit. We'll need to turn away because in the ISO view that will be, so we'll turn a little bit lower. Sorry, I'm not a professional sketcher dude on this board, but we'll come out and then we'll come here. That's better. That's better. So we'll bring this out. Okay, support there also. And then with this line going wherever it's going, back to what I was trying to say here was, once you put the new line in here, there will be some added stress points. Say this is a guide here and a guide here, right? So let's just call it a G. And then you got your vessel. The loads on this nozzle here, on this vessel here, are going to change. I'm assuming they're going to change depending on the temperature and the pressure of this line, but it's always a good point to bring up with your piping engineer, your stress engineer, that we are adding a load to this line that's never had it before. It's got a support point here. Why do I keep doing green? Let's go back to black. So this is a support point here and a support point here, and you follow it down. It's got a guide here, which is good, and it's got another support and support. So, and here I'm calling out a stop. So for that to come out pretty good, the existing line is supported pretty well, I think. But when you start adding this line here, the new line, it's gonna be I think it's gonna change the loads on here. And that's why you have a stress engineer to take a look at that. It's always good to bring this up. What else about stress? Or you may need to add another support close to in plan view. This is what I'm trying to show here. In plan view, we have the line coming out. Let's go back to green. We have the line coming out here and then coming up. Something like that. It's going in the rack doing what it's doing, but we're also crossing, say they're putting a guide there, and then yeah, comes down there. And then that's our tie-in point. So in plan view, that's what I'm trying to show, that there. And then stress may need to come back and add a support. Let's just put support in blue. They may want to come back and either add a support here, add some steel in here, or make this one common support. I don't know, something to think about. That may need to either to remove the load off this point here, and then to also make sure that the load on this nozzle is not passed, because this has got very minimal tolerances that can affect that nozzle, and you don't want to mess with that. But it's, as a designer, you need to bring it up of what you're thinking, of what the problem may be there. Let me go back, just put one. I think it would need a common support here. Oops, a common support here. So that would be a new support. Pipe support. So let's go back to the ISO view, see if there's anything I'm missing here for stress. Yeah, I don't think so. Let's go back to green. Let's go look at this tie-in. This tie-in here again. This line will need to be isolated. So maybe I should have drawn, they may need to either pancake this flange here, put a pancake in there to blind it off, or blind that off to isolate it. But in my scenario, for this tie-in here, I would go back. Let's ignore that for a minute. But for this scenario here that we're talking about, for this tie-in here, they'll need to isolate that, and then further down here, wherever this line goes, hopefully there's a valve in place, and then they can turn this valve off here. If they turn that valve off, then you got the line isolated, and now we can talk about removing this blind. So let's remove the blind and the bleed. Let's do something like this. So then we'll come in with our new line here. Go to a little thicker line here. So then let's just say this, we'll put in a flange, and then for this talking purposes, we'll put a valve here so they can isolate this stream or this system from the other one, which would be good practice. Since they didn't have it, it helps them out. It's a little bit costly, but it helps them out. And then this line can probably run in the next level in the rack. It'll go out. Let's say it'll go up and then down the rack somewhere. Anyway, the whole point is for this here, this has got a stop. So this tie-in here was located here. The reason I located it here was because it's close to the stop. There'll be no movement. this line won't move anywhere, or it's a fixed point. On tie-ins, I like to put fixed points as close as I can to a fixed point. Sometimes you can't, but it's just something that you got to look at, and it's good for the design and the layout. It helps out all across the board. Okay, so that's my thought process there for removing these blinds, and then they'll just do their bolt up connection here. And I'm assuming there's no interferences on either side of this valve, and there's clearance. In the rack, sometimes you get to where there's too much pipe going through here, and just gotta be aware of that. Let's go to the other one. Is the blind flange here that we're talking about. I mean, the nozzle flange that we're trying to talk about here has the valve on it. So this is a case to where I wanted to bring up that when you're talking to operations and they need a tie-in here at this vessel also, and they got a valve and a blind. It's okay. So operations, why is that blind there? Why is there no line connected to it? What do y'all use it for? Well, Mr. Garza, we need it for to access or to chemically flush this line or clean it or whatever the maintenance procedure is. It's good to ask that question. So you'll say, okay, well, we need to tie into it unless we want to cut in a new nozzle, and we can cut in a new nozzle, but it's gonna cost us time, and we need to get it approved by the let's just say the vessel specifications and the vessel standards, the codes that it's got to be when you cut into the vessel. So in this scenario, I would suggest, again, let's zoom in a little bit. Let's remove this blind here. And as a designer, you could suggest to the operations and to your process engineer, okay, well, I mean, they need the valve there, and we need to make a connection to this vessel. But in order for us to make the connection to the vessel, we need to leave them their access port, and however they need to get in there. So let me draw this. So then we can come back and put our tie in here, and then I would put a T. And then give them another valve. We'll add the other valve here. So then in this tie-in scenario here, then now I've got my connection type here. You're saying, well, why not give them, why are we adding another valve? Well, we're adding another valve because more than likely they didn't want to hydro test this piece of equipment. So if they don't want to hydro test it, then we got to leave this valve so we can hydro test up against this point here, right? So we'll test up against that point. More likely put a blind. Getting off topic, but trying to lay out some golden eggs here for y'all. And then, so on this scenario here, let's get back to that. Then I'll put a valve here for the project. Man, a little off here. And put a valve. Get a little shaky. And then we can go off and do what we got to do here. So in this scenario, we would still leave them their access port. So whatever they got to do to go into the vessel, of course we'll give them their blind back and their bleed. So this will all be part of our tie-in ISO. And I've done this in the past, and it's worked pretty effectively. And client appreciates it because we thought about why we were going to take up that tie-in point and what they used it for. So anyway, they will appreciate that. Anyway, enough of that. Let me know if you have any questions or if there's a scenario that y'all want to talk about. Not sure who I'm talking to, but anyway, hopefully there's a designer out there looking at this. Just leave me a message. So we've covered, let's see here. What color have I not used? The yellow. So we've talked about this type of tie-in. We've talked about the blind. We've talked about a bleeder. Same thing here. Yeah, these here. Let's see, we need to talk about these here. So we've talked about all these. So also some other scenarios for blinds that I'm thinking of that may come to in effect or that y'all are looking at are a lot of people do grassroots. Grassroots projects are normally, a new unit being added to an existing unit, or another complex being added, or something like that. So at the end of the rack, so I'm trying to show, here's the rack. And at the end of the rack, the project that did this project here, the existing, which is all in black, will pre-invest for a future unit, right? So that we're putting in out here a future unit, and then this will be the rack coming into it. So this is the future unit. I don't know why I did that, but anyway, let's go back to black, and I think it's that thickness. Nope, it was the other thickness, that one. So on here, these would be tie-ins. Red. Let's go to red. This will be tie-ins, tie points, tie-in. Anyway, y'all get the point. These are tie-ins. These blind flanges are the tie-in points. Same thing here, tie-in point. Tie-in point. And this rack is set up for, excuse me, staggered flanges. So with the staggered flange spacing, so what the spacing I'm talking about is here. So it's really, that's not the dimension. The dimension, when it's staggered flanges, let's see if I zoom in here. So this is spacing here and spacing here. So this is the minimum spacing depending on the flange, depending on insulation and so forth. So it'll be outer flange to the outer flange for that type of spacing. But anyway, these valves here have a can be isolated because they have the valve there, right? The valves are here, 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 and here. This one does not have a valve and not have a valve. Since I don't know what these are, I'm assuming these are utilities. So if these are the utilities, the whole utility system will need to be brought down. Typically, they'll leave a flange or a valve for process lines. But anyway, just past experience, that's been my scenario. A tidbit here, now that I'm thinking about it. So if you got, like I said a few minutes ago, you got the new unit out here. And then you probably continue the rack and whatever it's going to do. So the new unit here. More than likely, this will become a battery limit. I wasn't going to go into this, but let me go into it since I'm here now. So in the new unit, let's say green. This will be a battery limit here. Just something to be aware of. Sometimes these turn into battery limits, valves that they'll add more to it. But just something to think about when you're doing your tie-ins. And then more than likely, the new project is going to want to add a new valve, a bleeder. Oh, what am I doing? They're going to want to add a bleeder, green. They're going to want to add we'll add a spool piece. They're going to add a valve. And then they'll add a bleeder here, which will be in the vertical going down. And this will become a double block from the new unit to the existing unit. Anyway, getting off topic here, but this needs to be looked at. Let me zoom out a little bit here. I tried to cover everything here that I was. Let me take a look at my notes here. I think I'm finishing it up. Layout design, the line will need to have a I didn't cover that, but the new lines will need to have just make sure that they have a high point and a low point. So sometimes you'll need to come in here and put a high point vent on your design. 3/4 inch or 1 inch, depending on the client. And then here you may need to add another bleed. This is just for hydro. Just take it into consideration. This one here will probably need a high point here. I'm gonna make a video just on high point, low point drains. Cost center in Mumbai, and sometimes they have a hard time understanding why we need low point drains at certain places. But anyway, I'd like to cover that one more in depth sometime. But anyway, this is my overall view, and try to describe tie-in, remove blind flange, and bolt-up connection type. I'll try to make some more videos on this. Understanding the design behind blind flange connections and bolt-up connections ensures the maintenance activities are preserved for operations and for maintenance. I tried to cover that here too, but that's what I'm thinking is all inclusive with the bolt-up type blind. Anyway, if y'all have any questions, drop it in there. I would like to help as many people as I can, pass it along. Just thoughts and experiences that I've had and my sketching and my notes.